and so everything kind of aligns and it makes sense. The next one here, let's see, I'm choosing between two long-distance telephone plans. Plan A has a monthly fee of $20, 5 cents per minute. Plan B has a monthly fee of $5 with 10 cents per minute call. At what number of minutes of long-distance calls will the cost for the two plans be the same? So I'm going to have to write two equations, one for Plan A, one for Plan B, and then it says when will they be the same. So it's basically write two equations, right? One for Plan A, one for Plan B, and then set them equal, because it says when will they be the same rate. So first equation for Plan A. For Plan A, the equation is $20 plus 5 cents per minute, so 0.05 m. So m is going to equal number of minutes here. M equals number of minutes, and then Plan B, if you read here, it's $5 plus 10 cents per minute. So again, I have to write an equation, one for Plan A, one for Plan B, and then it says when will these plans be equal. So when will these plans be equal is literally saying figure out how many minutes would go, get used until these two plans are equal. So aka if you set these two equations together, one for Plan A and one for Plan B, you can figure out when they will have the same number of minutes to have the same cost. So let's see here. I'm gonna subtract this 0.05 m over to the other side, and in the same line I'm gonna go ahead and subtract this 5 over to the left. So one thing with variables on both sides is you're going to move the variables to one side and the constants to the other side. So if I move my variables right, constants should move left. So 20 minus 5, that's 15. This zeroes out, 5 zeroes out, and 0.1 minus 0.05 is going to leave me with 0.05 m, and 15 divided by 0.05. Let's calculate that real quick. And it's 300. So let's see here. So at 300 minutes, the two plans will be equal. We're just going to say A and B will be equal at 300 minutes used. Again, that's Plan A. Plan A and B will be equal at 300 minutes. Okay, so one more here. Costs for two different kinds of heating systems for a 3-bedroom home are given below. Solar cost to install, then the cost per year. Electric cost to install, and then the cost per year after that. After how many years will the total cost for solar heating and electric heating be the same? What will be the cost at this time? So same thing as the last one. So the solar is going to cost $29,700 for 9,700 plus $150 per year. The electric is going to cost $5,000, but then it's going to be plus $1,100 per year. When will they be equal? Same thing as the last one. You set the two equations equal to each other. So 29,700 plus 150y equals 5,000 plus 1,100y. I'm going to go ahead and subtract this 5,000 over. So I'm moving my constants to the left, which means I'm going to move my variables to the right. I'm going to subtract 150y. So 29,700 minus 5,000 is going to be 24,700. 150y zeroes out, 5,000 zeroes out, and then 1,100 minus 150. So that'll be 950y. Divide both sides by 950. 24,700 divided by 950 equals 26. So all we're saying here is that after 26 years, the two plans will finally have the same total cost. And then it says, well, what will that cost be? So Since the cost will be equal, it doesn't matter which one I plug into, I should get the same answer. So I can take 5,000 plus 1100y, remember y was 26, it'll be equal, 1100 times 26, plus that 5,000, 33,600. The cost when these two plans are equal will be, so after 26 years, the plans will be equal, and the cost at that point will be $33,600. And you could even double check, you could even use this equation. If you plug 26 into 150, again 150 times 26 and add 29.7, you'll still get 33,600. So again, if you took the other equation, 29,700 plus 150 times 26, you still get 33,600, because remember, this is after 26 years, that's the time when both plans will have the same cost.